Okay, so are you ready to do a little review? Let's go ahead and review our Chapter 7 information that we learned over the past, week or two, especially since you have a test coming up Friday. Wink, wink, nudge, nudge. Alright, so in Section 5, we divided exponents, and really what we were dividing are numbers with the same base and different exponents. So if you have x to the 5th over x to the 3rd, you subtract x to the 5 minus 3, which would give you x squared. Alright, so subtract them. And also remember that if you have x to the 3rd over x to the 5th, this is the larger exponent. So when you do the subtracting, instead of that x squared being on the top, it will go on the bottom because that's where your larger exponent is. Raising a power to a power. Multiply the exponents. Alright, now if you see an example like this, remember that you raise everything to that power, so you take this 2 and you use a modified distributive property and apply it here and here. Now when you are doing this 3 here, raising it to the second power, you are not doing 3 times 2, okay? You are taking 3, taking the first power, which is its exponent right now, and multiplying it by 2. And then same with y squared, multiplying by 2 to give you a total of 3 squared, y times y to the 4th, simplified, 9y to the 4th. Multiplying numbers with the same base, you add the exponents. Okay, and remember the other important thing, keep the base. Okay, so add exponents and keep the base. If you have 4x squared y times, let me erase this stuff, get it out of your way, times y squared x, you find the ones that are alike. X and x are the same base, so we keep the 4. X would get 2 plus 1, and then y would have here and here, 1 plus 2, simplify, 4x to the 3rd, y to the 3rd. Scientific notation, number between 1 and 10, so 2.5 times 10 to the negative 5th. Negative means move to the left. And if it was a positive exponent, you would move it to the right. 0 and negative exponents, anything to the 0 power is always the number 1. And then if you have negative exponents, remember, negative exponents, that this does not mean, it does not mean negative base. Okay, we were struggling with that in class today. So if you have 4 to the negative 3rd power, this is not the same as negative 4 to the 3rd. Alright, negative exponent means small number. Alright, so this, what it does mean is small number. Alright, so what 4 to the negative 3rd really is saying to you is to switch its placement in the fraction. So we would flip it to the bottom. Let me just write it over here so I have some room. What this really means is 1 over 4 to the 3rd, and then we simplify that to be 1 over 64. Okay, so there's the Chapter 7 with exponents. Now we're getting into Chapter 8. We're continuing with exponents, and now we're just applying them in a different manner. So we're starting with adding and subtracting this thing they're called polynomials. Okay, now if we look at our first vocab word, a monomial. Now you all know that mono means 1. If you don't know that, then you do now. So 1, an expression that is a number, variable, or product of a number and variable. So this would be a monomial. 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 So really what it is, let's say we had 4x plus 2, we can't combine them, but this would be a monomial, and so would this. Alright, so anything that is before or after a plus sign or a minus sign. Those are all your monomials. Now, if you have a degree of a monomial, it's the sum of the exponents of its variables. So if we look at this 0, that's the degree up here. Okay? The reason is because there is no x. So for that one, if there is no variable, the degree is 0, because we know that x to the 0 or anything to the 0 power is 1. So if we really had 3x to the 0 power, that would be 3 times 1, which is just 3, which brings us right back to here. All right? And then moving on down the line, we have this would be 1, because that's the exponent for this variable. The degree of this monomial would be 3, because that is the degree of that, or that is the exponent, I'm sorry. And then this last term would have a degree of 6 because it has a 2 and a 4. So you add them. Okay, so we talked about a monomial where it's just one term, and now we have polynomials. Poly means many, and I know you have learned that before, but you know, you have a tendency to forget little things like that. So, polynomial. It's a monomial, so any of these terms here by themselves, or the sum or difference of two or more monomials. Okay, so again, if we look at this, each individual term here is a monomial. This is a monomial. And then we move down the line, a positive 5x squared, that's a monomial. If we keep moving, negative 7x is a monomial. And then our last one, plus 1, that's a monomial. So each one individually is a monomial. To have a polynomial, we're adding in these signs here. Plus, minus, those types of signs. We're adding things, subtracting things. And then this is just another example of using the degrees and how they apply. 4, because that's the exponent, and so on. To have standard form of a polynomial, so this again, polynomial, all right, up here, this is your polynomial. To have it in standard, the largest degree comes first and then decreases, so put it in order. So this one is already in standard form up here, so that's already standard, because it goes 4, 2, 1, 0. All right? So even though there isn't a 3 exponent, it's in decreasing order. So if we wanted to write this example down here in standard form, first you have to identify each monomial's degree. So we start here. The degree here is 2. And then we have a second monomial here in the middle, the negative 2y to the third. This negative symbol out here does not mean anything, okay? It just means that the coefficient, the 2, is negative. It does not have anything to do with the actual exponent itself. So the degree for this one is 3, and then our last one, the degree is 0 because there's no variable. So we would have to write it in 3, 2, 0 order. So when we do that, remember to keep that minus sign with your 2y cubed because it's negative 2y to the third. And then we will add on, remember we're going descending order, so the one that has the degree of 2, which is 3y squared. And then our last one, which is 4. And you'll notice if you actually look at any examples in the book or online, you will notice that almost every polynomial will be written in decreasing order. If it isn't, it's because they're going to ask you to put it in decreasing order. Okay, so I figured you probably need a little refresher on like terms. What can be added, what can be subtracted, what can't. And the reason I say that is because we're getting into a little bit more complicated variables. So if we had something like x squared times y, and then we had 3yx squared. These are like terms, and the reason behind that is because they both have x squared times y. Remember, you can use the commutative property to change the order of these. This right here is the same as 3x squared y because of the commutative property. Okay? So there's one example of like terms. Another one could be negative 4z to the third y squared. Oops, sorry. And then let's say just 10 y squared z to the third. And again, this is just the commutative property. Both have only z to the third and y squared. All right? Now, if we're talking about terms that are not like, and let me just kind of modify the examples we have under the like terms. If I gave you the number or the variables x squared y, and then I changed this to be y squared x, this is not the same because in the first term x is squared and in the second one x is not squared. So those are not the same. All right? And then remember, you could also rewrite that even if it looked like it using that commutative property, rewrite xy squared. Again, not the same thing. X is squared here, but not here, so they're different. And another example could be something like 2x and 3x to the third. X is not the same as x to the third. Okay, these are not the same thing. So we can't add or subtract anything in this column here from one another because you can't combine them if they don't look exactly identical like they do in this column. Okay, so now I know what you're thinking. How come we can multiply anything by anything? So in the last chapter we were multiplying all sorts of stuff, but you can only add or subtract like terms. Well, think about what multiplication actually means. So multiplication, what it means is how many groups, oops, I started getting ahead of myself, how many groups of something, okay? So if you see something like 2 times 3x squared, what that really means is you have 2 groups of this term. So you have 3x squared once, and then you have 3x squared again. Okay, that's what this 2 out here means. Now if you're adding them, so if I wanted to add 2 plus 3x squared, 2 is a number, an actual number. We know what 2 is, and we know how to actually use the number 2. But 3x squared is not the same because of this x squared. We don't know what x is equal to. We don't have an equation. We don't have any way to put a value in there. And because of that, we need to leave it separate. Okay? So multiply anything, and then you can only add or subtract terms that look the same. Okay? Now, let's do some adding of these polynomials. One thing that you'll notice with this example is you'll see these parentheses here. Most often, this is just showing you we want to take this term and add it to this term. Just showing you that they're from 2 different places. Maybe a length and a width, for example. Or one score and another score. It's just 2 different things. The parentheses went with addition. So with addition, the parentheses have no meaning. Alright, there's just none other than showing you it's 2 groups. So all we have to do is take away those parentheses. So I'm just going to write this again, 5x squared plus 3 plus 2 plus x minus, sorry, this is freezing on me, minus 15x squared. Then from here, what I'm going to do is use the commutative property to group together my like terms. This has an x squared with it, so does this term over here. Remember that this minus sign goes with it. So I'm going to write 5x squared minus 15x squared. All right, now as we move down, we have these two that are like terms because they are just numbers. So plus 3, plus 2, and then we have our Lone Ranger out here, this x. It is not a like term with anything because nothing else in this whole expression has just x. So now we do our adding and subtracting. Don't change this x squared number because what 5x squared means is that you have x squared, you have 5 of them. Okay, so you have 5 different groups on and on. All right, so when we add these, keep the x squared as it is. You don't change this. We're changing the quantity. How many x squareds do we have? So we have negative 10x squared when we subtract here. Now with this 3 and 2, we have 5. And then, of course, our Lone Ranger out there, we have x. If we wanted to write it in standard form, which I will tell you now, you should always do that, the negative 10x squared comes first. And remember, that's because of your exponent. Okay, the exponent is the highest of all of them. This negative out here has nothing to do with where it goes in the position in standard form. And then our next one we put would be plus x because the degree of that is 1, and then plus 5. So just going back to the beginning, the degree here is 2, the degree here is 1, the degree here is 0. So decreasing order left to right. Okay, now if we were to look at this example and express the perimeter of this rectangle in standard polynomial form. So all we're doing is adding and subtracting like terms. Perimeter means add all sides. So add all sides. All right, now when you see rectangle, you know that a rectangle has opposite sides that are congruent. So if you see something marked like this, that means they are the same. So if this in the top is 2x squared minus 4, well, guess what? So is that one. And if this over here is 3x to the third plus 2x, then again, so is this one. Now we're adding. So all we need to do is group together our like terms. We have 2x squared, all right, and we have another 2x squared. So those are one set of like terms. Now if I'm still going to deal with this information here, I have minus 4 and another minus 4. So minus 4, minus 4. As I move on, 3x to the third and another 3x to the third. So we're putting those in. And then we are left with our last, which is our 2x. And we have 2 of those. All right, combine them. 4x squared. That means we have 4 total of this item. Then we have minus 8 because there are 2 negatives. Then plus, how many x to the third do we have? We have a total of 6 of this item, and then a total of 4 of that item. And then to put it in standard form, decreasing order. Here is degree 2, 0, 3, and 1. So if we wanted to write this in standard form, we would go ahead and write it out. So let me put standard form up here. The perimeter would be expressed as 6x to the third plus 4x squared plus 4x minus 8. Okay, now with subtracting, here is where the parentheses matter. All right, this part is really important. Here's why. With this minus sign, you need to distribute that to every single term. All right, because what you're subtracting is this whole polynomial. If you don't distribute that, you've only subtracted the first term. But really what the parentheses are asking you to do is to subtract all 3. So after we apply the distributive property, we don't need to write the parentheses anymore. Negative times a negative would give you a positive 2w to the third. Negative times a positive would give you negative 4w squared. And then negative times a negative again is positive w. group together your like terms. This first term here does not have a like term because nothing else has a 4 exponent. Our w squared has a like term right here with negative 4w squared, and then we have 2w to the third does not have a like term with anything else here, and then our positive w, which also does not have a like term. Combine them, write them in descending order. Negative 6w to the fourth, followed by 2w to the third. I don't know why that just happened. Sorry. Followed by these two combined right here. 1 minus 4 is a negative 3w squared, and then we have plus w. Decreasing order, 4, 3, 2, 1. One more example of subtracting, and then if I'm not mistaken, we're done. Yeah. All right, so subtracting. Remember, parentheses means that you have to distribute the sign. Don't forget. All right, because that will be the fall of you. You will struggle. All right, so distribute x squared minus 2. We keep this first term as it is, distribute that negative, minus 3x and then minus 5. Now combine all of your like terms. If you look at our example here, x squared does not match anything, so that's going to stay. All right, now as we move on, we have negative 2 and then a negative 5, and guess what? Those can be combined to a negative 7. All right, and then our last one, our lonely negative 3x with nothing to combine with. I just want to make that prettier so you can read it better. So minus 7 here. All right, and then standard form, as always, the degree for our first term here is 2. Then we have 0, and then we have 1. So we start with the highest, x squared, and then we work our way down, minus 3x, and then minus 7. And there you go. All right? So remember, and this is very, very, very important, that you cannot add things that do not look exactly identical unless you can move them with the commutative property. Okay, so when you see, for example, when you see, let me get to a different one, this right here, okay, we are saying we have 5, let's say, apples. We're taking away 15 apples. How many do you have? Okay, the apple itself is not changing. It's not becoming an orange or a banana. It's not becoming a watermelon. It's staying apples. We're just changing how many there are. What's the quantity? Okay, so just think of each variable type as a quantity. And if you look over here, this is a term. It represents a number. We don't know what. So think of it as how many there are of this kind and how many there are of this. And because there are the same, we could say pens and pens. We have 3, we have 1, so together we have 4 of those pens. So this would actually become 4x squared y if we were to add them. Okay, so do not change the item itself, change the coefficient, change the number. Okay, so change coefficient only. All right. Well, go ahead and write your summary. If you have questions, let me know. Otherwise, I will talk to you again soon.